Okay, it's noon time, Central Time, noon time. It's 10 o'clock Pacific time, so we'll get started. First, what I want to say is the schedule. Okay, so the class will end this week. Okay, and then I have to emphasize one more time is the due time of the homework. Absolute due time is here. Actually, Sunday 15. The 11:59 p.m. Central Time. Okay, so that would be the sure dead time, 100, 200% sure dead time. So any submission at this time will not be accepted. Okay, and then I have the whole Monday to grade and tabulate your final score, and I need to submit 8 p.m. Pacific time in a Tuesday, and actually it's 10 a.m. I'm sorry, 10 a.m., not 10 p.m., 8 p.m. 8 a.m., not 8 p.m. So 8 a.m., that would be 10 a.m. Central Time. That's the time I need to submit the final score for all the students. So I need to use the whole Monday to do tabulation. And then, so please submit before the end of the day in Sunday, okay? I will not take any late submission after that, okay? That's the first things I want to communicate. Make sure you do submit before that. And another thing is that a few students, I'll say maybe 90% of the students already stopped learning, okay? Not even studying the material that we have. How I figure it out, because many students in homework 5 or 6, they either missing the kinematic diagram or hand calculation, or they do work on the kinematic diagram and calculation, but they submit something that's weird. We have a rotary joint, and then we have another one that actually prismatic joint. And then how come your Denby-Hartenberg matrix has theta 1 and theta 2? There's only one theta. There's only a rotary joint. How comes that maybe 70% to 80% of the student in their homework 6 or 5 or 6 submission, either they miss the kinematic diagram or they have the kinematic diagram, but they have the Denby-Hartenberg matrix, but they use theta 2. That's weird. You only have one joint. How come you have the theta 2? So those students completely not working on the material right now. That's the part that's scaring me. Scary. Okay, I actually got scared. Like majority of the students are not even studying. That's the problem. Okay. So those that if you are a student who give up studying, please work on it. Okay. This course is supposed to be an introductory course, and we've already tried to minimize the difficulty of the material. And also in terms of grading, I already make it very straightforward and simple. Okay. If you do work on something, even you miss some numbers, I'm fine. Okay. I don't deduct point if you just have some minor issue in your coding or in your modeling. But if you totally don't want to try, then I can see it. Actually, some students start to give up in homework 4, some start to give up in homework 5, okay? And that's another good sign. In terms of so many years that I teach robotics, this class has many and the majority of students who give up early and just try to submit some garbage homework, okay? That's the problem. Okay, anyway, any questions so far? We have only one student, but I don't know whether he has question or not. If not, then I will try to finish this session early because this Monday session is supposed to be a question and answer session, but I don't think that some student is checking course right now, so I'll try to finish up this session early and then give student more time to work on it. Okay, work on the final project or homework. Okay. One question: will you get a extra bonus for participation? Yes, I may. Okay, I just say I may. Especially you show up in the last session for only person, I will. Okay. Anyway, I'll continue to finish up this whole session quickly. Okay, since nobody really interested in this participating. Okay, so lecture 15 is finite state machine and control implementation. Last time we talked about a low-level loop. Low-level loop being the electrical electronics loop. So we do have some feedback system that form a dynamic system. So we need to use the Laplace transform for the analysis of dynamic system. And right here, we are talking about a different kind of control loop that is a higher level loop. That is control unit data path and also controlling the motion of your robot, okay, your action, your movement part. Okay, so anyway, uh, today we are talking about the robot control through the finite state machine and then the PID controller using FPGA technology. So first we talk about a finite state machine. So, okay, so finite state machine offer an alternative for combined uh, behavior. So you have the forward, okay, behavior. You have the turn right behavior. Okay, so like this one, we have this Pac-Man. Okay, if you want to control it, so it will forward for 2 feet, and then there's a turn right 90 degree, and then forward for 3. So it forward, turn right, and forward. Okay. So this is what will happen. And then there's a sensor needed over here. If it actually sense that it already is hitting the wall. Okay, so basically you start from there, you forward for 2 feet, and you sense there's a wall, and you turn, and you move forward again. Okay, and then you move forward again. Okay, next one. Actually, you can design a finite state machine so that there is a forward mode. Every time you forward for 1 feet, 1 foot, okay, 1 foot, and then the next one you forward for 1 more foot, okay, and then you will hit the obstacle. So if the obstacle is within 2 feet, you will turn right. Okay, you turn right 45 degree. If 45 degree not enough, you still see the obstacle, then you turn another one. Okay, so by this one, you will do that. Okay, turn 2 times and then forward. Okay, so this kind of the control just have 2 state. It can be implemented by such a Python code. Okay, I'm sorry, this one is actually Java code. Okay, such a Java code, and then you have 2 state. And then there is a sensor that will sense the distance to obstacle, and then you will change your state. Okay, these 2 things that you would do. Your state machine would be like that. Okay, so it's a simple implementation of such 2 state machine. So this is a very simple example, but just tell you that you can use a state machine to control your robot movement. Okay. So a more complicated state machine is like this. Okay, you have more state, and then you will sense the distance, and then see if there's a ball or not. Okay, something like that. So many states. So here you actually will go through this final state machine control using some algorithm. Okay. So you have a controller, you have a sensor, you have image camera thread. Camera was sent to the controller to analyze for the data that they sense. And then the controller will take movement. So implementation wise like this. And then you actually will control the servo, okay? So the design of final state machine is in Python language or maybe Java language. It depends on your implementation, okay? Depending on your implementation. So that actually is a simple final state machine control. If you change your final state machine control to a microprocessor, that actually is also fine. Okay, that actually is also fine. Okay, next one we have the coding. We have the coding for final state machine model. Next one we talk about a PID controller using FPGA. This one is last time we do have the system diagram that in electronic component like this one, you have this kind of proportional integral and the differential equation. So this you put it into electronics, something like this. And then the PID controller usually is use of the resistor, inductor, and the capacitor to design it. This portion can be done by a discrete. Discrete means the digital implementation for it using differential equation. Okay, and then that one being break down into PID equation with digital part. Okay, and then you have many coefficient you need to work on. So after that, you actually can derive a digital PID controller architecture, and then you implement it. Okay, you implement it into hardware. Okay, so this is one example, and then you use a timing diagram analysis to do a simulation and to debug it. Okay, for your FPGA part. And then you can send out a control signal at the right time to implement it. Okay, and finally, sum up the architectural result. Okay, whatever. This is only a short simulation result. So that actually one example of using FPGA to design the so-called PID architecture. Okay, this one is a transistor level. I'm sorry, this one is a register level transfer diagram. Okay, RTL. Okay. It's a question that do we need to record video for PPT presentation or just submit PPT for final report? For Krishna's question on this one, actually either way, okay, we take both. If you just submit PPT, is fine. If you have time to record video, it will also be fine, okay? The PPT, you don't need to cover too much technical part. We just want to see what you have done so far. The PPT is just presenting what you have done so far and how they work, okay? We just need to know that. And as for the detail technical discussion, you put it in your write-up. put it in your final report, okay? So PPT is for presentation, it's not for final report. Final report, it should be done in Word format, okay? Or some sort of Google Doc format, okay? So that's about the technical part. So we need three things: your coding, or your implementation, and also we will need your video or PPT. Okay, video or PPT, you can choose one. You can also submit both. Okay, either way, and then Word file. Word file is for technical discussion. Okay, PPT you don't put a lot of equation. We don't read that. Okay, we just need you to show us how it works. Okay, so here we have another second order control loop, and then a lot of system analysis in electrical engineering terms, okay, frequency domain. So they have the omega zero, okay, that's the angle. So whatever, this one, actually they have we have different analysis. So this is a second order equation. After simulation, you will get something, okay, actually this one is trying to see is a time domain response. Okay, whatever, and the shooting problems for system stability analysis. Okay, so anyway, that's just showing you that when they are done in FPGA or the PID controller, you can have those kind of performance. Okay, this is the high-level architecture in lecture 15. Okay, so another one is the final one is the robot architecture. We call mobile robot. Okay, as you can see, actually this set of the node, I totally have 16 lecture because originally this was designed to be a one full 16-week course. So right now we are 8 weeks, so it's kind of 2 lecture per week. Okay, so we are shortened. The original goal is to build a course share that can be shared by 16-week semester and 8 week per semester. Okay, but 8 weeks are supposed to work in the double effort accelerated format. Okay. Okay, anyway, this one is talk about mobile robotics. So talking about its control architecture for the wheels, for the legs. Okay, so this is called mobile robot. So mobile robot, actually, you do need to sense the environment, and then you need to build up the environment control. So basically, this is the control loop. Okay, sensor, planning, and then provide control. Okay, and then look at the environment. So there are a lot of, let's directly jump to the case study. So right here, we do have a disk rolling on a plane. So disk rolling on a plane is that you control a single disk in rolling on a plane. Okay, and then control is this small thing to turn to make a circle or something. Okay, this is called this kind of control. So if you are mechanical control, the response time is actually very hard to achieve. But since you are using digital and smart control, so you set up the control variables to control it. And in fact, this can be done nicely. Okay. Let's look at a number 2 case. Number 2 case is you need to set up the control variables for 2 dimensions. Okay. So that this rolling on a plane can be modeled, okay? They are a lot of mass anyway. And then next one is unicycle. Unicycle is like only one control cycle, two wheel that's not moving. Okay, two wheel that's so actually it says a tricycle, but only one wheel is actually providing the control. Usually this one is at the back. Okay, so you only have one actually driving your car, control the direction. So here it does give you the control over the unicycle. Okay, unicycle is the control when you move your tail wheel to control it. Okay, anyway. And then you may have a three wheel and all three wheel are moving or turning. This is called synchro drive mobile robot. Okay, so you may have three of them that actually moving at the same time. So that's actually called synchronized. But these three are synchronized because they turn the same direction at the same time. Okay. So in terms of mass model, it's similar to the unit circle. Okay, unit circle. Okay, anyway, next one is a bicycle. Bicycle is that you have two wheel, one is controlling, okay? And then you set up theta and length and phi, okay? These are something you actually work on and then you performing the analysis, okay? And then you got a equation for US control variable and the XYZ, okay? Something like that. So what we want to say is that no matter it's a unicycle, bicycle, or synchronized wheel, what you want to do usually is set up your control variable and then link it with your XYZ domain variable. And you may also need to work on the differential equation in order to analyze them, and then you will get some model, mathematical model of how to control them. Okay. So you also have car like mobile. This may be front wheel drive or back wheel drive car model. Okay. And that's about it today. That's what I want to say today. Okay. Let me check the problem question. About the R3 SIG part, we do have a video. We talked about it for a long time. So you just need to watch the video. Okay. What I see from your homework is that your quiz that your numbers are totally off. You choose the wrong way to do it. As for what way you work on it, I don't know because your answer is totally off. None of your answer is correct. So you have three problem A 9, 10, and then you have three metric for 9 number each, and none of the number is matching. Okay, none of the number is matching. So the way I do grading is very easy. Each one of the selection is 1 point. If you just nothing is correct, I'll give you 1 point. Okay, if you have nothing correctly. So I do have my simulation result. So every question in the quiz, I always have the number. So I just show you that every single one of them, I do have the answer right here. Okay. I'm using my simulation, the calculation result to match the answer, and that have been verified for many years. Okay. You have to watch the video. Okay. I don't repeat the teaching. This one, if you study our week 6, week 7 for the 7 rules for calculating the metric, it was included. So I doubt that you never study, okay? You just watch the week 6, week 7 video. They are there. So I don't repeat for it. It's included. I'm very sad this time because most students not watching the video, not even studying, okay? And they only care about score. So if you work on the video, we talk about 6 degree of freedom part. Let me see, not this one, that is controller, no, that is okay. So this one, like this one, the Jacobian metric for Stanford manipulator, they do have it, okay? They do have it. This one will give you the similar modeling that you need to solve the week A. And then this lab 5, let me see. Lab 5, we have Jacobian metric, okay? Anyway, that's what I can say because a lot of students just skip the lecture and lab, and that I cannot help you too much. In a way, this is a shortened course, so we only can give you some sort of introductory study, okay? And then the key point is that we cover as much topic as possible in the robotics so that later students can explore each individual field by themselves. The problem that we have is that we only have an 8-week course. It is short and we need to do a lot of things. And then typical robot course in Berkeley or Stanford is actually 2 semesters, and each semester has 16 weeks. So it's actually 4 times the time that we have. So we cannot even be, I would say, we just maybe one half semester compared to what they have. Very hard to teach too much, okay? But we still need to cover every corner that we have. So it's actually a intensive course, and we expect students to be able to go over it with some depth. So we cannot even just teach something that actually useless, very simple, okay? That actually not going to help students to understand the whole field. So our goal is that providing enough mathematical background for students, but some students do not have the math that requires. For example, some students never take the differential equation, never take the multivariable calculus. And then, yeah, so when we talk about Jacobian differential equations, that probably too hard for them, and that I know. So I try not to deduct too much point out of the students' project. As long as they try a similar way, then I'm fine, okay? And also those code actually, no matter it's Jacobian metric or whatever, we actually include it in the download section part. You can always download the code to run it. So a student miss some point or cannot work on it, can only say that they try to skip something, okay? And a lot of students just jump to homework, never study. That's actually a very, very bad habit, okay? And you Okay, for some easy course, maybe that's okay, but not for this course. Okay, we are a graduate school robotic course, so cannot be that easy. Okay. Okay. Anyway, before we finish, I still want to emphasize one more time. The absolute due time is 11:59 right here of the Sunday of the 15th. Okay. Any submission after that will not be accepted. That's what I want to say. Okay. Okay. Anyway, any other question? Joseph, how are you?
All right. I actually did have a really quick question.
Yes, go ahead.
You said it's supposed to be Sunday, right? Sunday at midnight. Is that right?
The end of Sunday.
Yep. Okay. And then in terms of video formatting, what is the maximum time you wanted on those? Was it you said it was 5 or 10 minutes?
I would say up to you. You only have 1 minute. That's also enough. The key point is that in the presentation, no matter it's a PowerPoint or the video presentation, I only care about one thing, what you have done and how things work. That's the only thing that I care.
Okay. Thank you.
So for the presentation, just show what you have done and how it works. As for technical discussion, please put them into your write-up. You do have a final report, so you need to have some sort of formal writing in your Word file. Is that okay?
Is that in tandem with the video?
No, that's different.
Okay.
Video just purely how you work, purely how you work and how you have done it. So you see some video, actually some student just showing me the time uh, lapse video of how they assemble their robot. That's fine. That to me, that's fine. That show me how it works, right? And someone show me how the robot arm get control. That's fine. Okay, but in your word, that's your final write-up. That's different. You need to, some people put equation there, some people put simulation result there. That's fine. But in the presentation, I don't need those coding. I don't, some student put a lot of equation in the PowerPoint. I don't need that. You know what I'm saying? Those equations supposed to go to the final report. Am I clear?
Yeah, no, absolutely. Yeah, I built a robot for mine, so mine's going to be the time lapse with
So
chat stuff.
anything you study or anything that related to theory or anything you want to discuss, put on the document, put on your word write-up. Is that okay?
Yep.
Or Google Doc is also acceptable. Show me the your Google Doc. I will also agree. Okay. And those are something I look for. But in your video, just clearly show me how it works. So 1 minute is enough. Okay, shorter than 1 minute, I would say too short. But 1 to 5 minutes normally okay. 10 minutes fine, but don't give me a 1 hour presentation. Okay, that's actually too much. Okay,
Yep, for sure.
let me see. Yeah, you include the assembly, that's fine. Okay, and you present assemble process, you probably half of your, maybe 1/3 or half of your uh, final presentation. Another 2/3 or half, I was supposed to see how your final result is. So that means that how you control your robot, how you maybe run. Okay. And but if your robot is not fully functional, that's also fine. Just show me how it works. The working part, the non-working part, you can avoid it. I'm fine. I don't consider that as cheating because in such a short time, you cannot actually remove every bug. Okay. So as long as you show me which part it works, that's fine. But don't get a fully functional robot from other people, then that's not what we want to see. Okay. So if your robot is partly functional, that I'm happy because you at least show the part that is working. Or even it is not working, you just show me the example stage. That's fine. Okay. I know you put time into it. That's good enough. Okay. We are judging your creativity, your how you work on it, those kind of things. But we actually, if the robot doesn't is not fully functional, I'm okay. Okay, at least I'm not the kind of person just want to see a perfect robot because we push for perfect robot. Then some students just get the robot from someone else. That actually is cheating. Okay, then it defeats the purpose for preparing student for a job. Okay, that's not what we want to say. See, we want to see student really work on it, and it is bumpy. That's bumpy. Okay, that's the nature of the project. Okay, it's okay. We don't seek for perfection. Okay, is that clear?
Yep.
Okay. Any other question? The overall goal is that this is a shortened course, just 8 weeks. So we try to start quite a lot of things. I know. So some students may not have a mathematical background or never do modeling before. So we feel very stressful. That's normal, okay? But we try to make it easier because I usually make deduction, but not really give you a zero, okay? So hopefully you can enjoy it, okay? Hopefully you can enjoy it. My purpose is not to fail everyone, but just wish to have students get a good start in terms of knowing, oh, robotic is something like this. You need to do modeling. You need to build a machine. You need to do this. Okay, that's the purpose of an introductory course. So we cannot go for perfection. So if you cannot do something that actually is fine, okay, we don't give you a C because of that, okay? Because of your deficiency, because some students do not have the complete mathematical background into modeling, okay? And some students may not know Python well. We all know that, but I just want to see you work hard by yourself, okay? That's the purpose, to lead you into this field and also knowing about everything that's needed for robotics and knowing about the future of the robotics. That's the goal, okay? That actually is a goal. And this is an 8-week course, so we cannot really force you to learn everything in such a short time. And also, students coming from different backgrounds, so not a lot of students really have the right background. Can you guide us how can we get a job opportunity nowadays from your experience? Can we get feedback, suggestion in the current market? Yeah, if you have question regarding job market, I can help you, okay? Nowadays, yesterday, I still talked to a student. This student is CMU. Okay, I talked to him and his father, okay? This student is a CMU undergraduate student in electrical and control and computer engineering. So he got a perfect GPA 4.0. So he actually already got admitted to graduate school for CMU in the same school. So it's called like 4+1 program. Okay, they have a shortened master program. But over the 4 years that he studied in CMU, he never get any internship. I told him this is a problem, okay? people don't care about your GPA. Don't think that your GPA is important. So when you go for a job interview, GPA means nothing. Unless that your GPA is only 2, then I will worry about you are not really studying. Okay, as long as you are 3 point something, I think it's fine. Okay, nobody will care about your GPA if you are good enough. But the problem is you have to pass the interview. The interview part is harder. So a lot of students even don't get the interview invite. Okay, they never get any phone call or anything. So your resume must have some problem if you don't get any phone call. Okay, that's for sure. Second, you do not reach out enough company. Maybe you do not reach out the right people. That is the key problem. Okay, that's a key problem. As for how to reach the right people, you must actually know about more people. Sometimes club senior will help. Sometimes professor will help. Sometimes your friend in the industry will help. Okay, so you have to broaden your network. That's number one. And usually, if I get a resume from some referral student and some without referral, then I'll pick those one with referral. Okay, that's for sure. I think a lot of people do this. Okay, and the HR will also do it in that way to see if this one is referred student or not. Usually, referred student have higher priority. Okay, school doesn't matter. Okay, school doesn't matter. So if you present you have a resume from Berkeley or you have a resume from San Jose State, I would say they got equal opportunity in terms of the getting the interview. But usually, I would say still Berkeley student would stand out more compared to San Jose State, right? Because the quality of the education, because the students' awareness of the job market, and also because of uh, a lot of historical reasons. Okay. So getting the interview done is a very important part. It's a very important part. You actually have to get more interview before. Maybe you got 5 interview, you just one go to the final round. That's very typical as well. So you have to increase the number of submission in terms of resume. Okay, if you just apply for 3 school, I would say you are totally not aware of current job market. Okay, if you do 50 and doesn't get any response, that's also typical. Okay, I know a student who is actually a classmate of my son. Okay, and then he already 25 years old, but when he was in college, he's a mechanical engineering from Berkeley. So when he was in college, he sent out like 300 resumes and finally land a job after 300 resumes. Okay. So that's how difficult it is, even back 4 years ago. Nowadays, even harder. Okay. Recently, I would say even harder. But still some people manage to get a job, okay? Some people still manage to get a job. So number one, you have to have more internship during the 4 year of your undergraduate study, or if you are already in master program, continue to work on the internship if possible, okay? And the more you actually work on internship, the whatever recruiter would find you easier. So some job, okay, for example, my younger son's, he already in graduate school, but when he was in sophomore year, he tried to apply for some job in Wall Street for I would say for the software engineer for Jane Street or for what Citadel, those kind of company. So for example, Citadel, okay, I told him, oh, your number of internship is too few. We seek for student who has 6+ 6 more, okay, 6 or more internship experience before we would like to provide internship for a student. So they don't give him interview, and then they just want him to get more internship, okay, from other company. So there are some position like that, okay? There are some position like that. So some position or some company, they even look at how many internship you already have, okay? So over the year, you have to build up your own good record in terms of getting involved in the work before you have better chance, okay? And usually you go from no pay internship to $20 per hour to $50 per hour to $70 per hour, okay? Gradually climb up, okay? Okay, that's what I can suggest. But because some of the issue are related to your domain, okay, the kind of job that you apply for. So for those questions, if you need help, you can contact me from my email or my Facebook, okay. If some student need the recommendation later, okay, so if you got an A from this course, I'll give you recommendation later, okay? So A student usually means that you finish all the homework by yourself, okay? Any question? Joseph, any questions so far?
Nothing here, sir.
Nothing, okay. Okay. Job related, I cannot use other people's data, but I still show you my son's data, okay? That's the part I think is okay. So this is my son's LinkedIn page. It is in public domain, so I think it's okay to discuss it, okay? Okay, I'm sorry. So he actually, let me, education background, he actually got into Berkeley MET program in 21. Okay, so he worked only 3 years on this program to get 2 degrees, 1 degree in X, electrical engineering and computer science, and another degree from Haas Business School, or whatever that's education. And then he currently work on a master program at Stanford, okay? So that's the education, but I don't think education matter too much, okay? It's primarily your capability. So he has tons of experience. Okay, so since he was graduate from high school, he in that summer of the after high school, he worked on this one. This one, he actually worked on 3 intern. He worked on 3 intern, okay, and also one NASA intern, and then he go to the college, start to do internship as well. So he has tons of research at the university and internship. So up to here, when he's a sophomore year, he already have 5 interns, including one from Adobe. Okay, Adobe recently is doing quite well. Okay, this one actually is doing quite well. This one he actually work on the job as an intern. He worked on the intern actually. This is how Adobe worked recent 6 months. going for 300%, okay? A lot of money. Okay, this company he worked for in his summer after freshman. And then he go for a trading company in sophomore. And then he worked for a media as intern. This is a school year intern, okay? School year intern means that he's taking course from Berkeley. At the same time, he work as an intern, full-time intern for a media. So that's only can possibly happen when you are in Bay Area. Okay, that's actually. And then last summer, he worked for Any Scale. That's actually a AI company, okay? So now he actually get for the next year, he get an intern from Databricks and also OpenAI. He hasn't determined which one he will go yet, okay? So what I want to say is that over his 4 years of the undergraduate and graduate program, he worked for more than, so far, maybe more than 10 internship already. So you have to build up your own record step by step, okay? And robotic, if you are interested in robotic or AI, then your math must be very good, okay? So that's why we emphasize on modeling. If you don't have good math background, you're probably not easy to get hired by any job, okay? Okay, any other question? If not, we are going to be done up to here, okay? Any question? Okay, no question, then that's it for it, okay? You can still ask for seeking for my help, okay? If after the semester, okay? As long as you are my student, I will try to help, okay? Okay, see you next time. Bye-bye.